Hello and welcome everybody. My name is Dubravko Dolic. I'm from Continental Tires and I'm happy to give you some insights today in our visual perception provider, aka deep learning with image recognition, how we do it at Continental Tires. I'm very sorry that I can't be with you today live and on stage due to my COVID infection, but I'm thankful that I have the chance to present to you these content anyway. So, at the Tires, we realized very soon that we would need some kind of deep learning that helps us with our image recognition, and we dived into that topic already a while ago. This is normal because Tires is a huge part of Continental as such. We have a lot of employees working on the full chain of tire production in different locations, and sure, our strategy shows, as you can see here, that we are on the way to become more tech-driven, more data-driven, more efficient, higher output on quality. And from this vision that was stated by the management, it is clear that all kinds of AI, respectively deep learning, may contribute a part to this. So in the team of AAII, Applied Analytics and AI, we support the whole value chain here, the whole value chain that contributes anything to the creation of tires. So starting from really R&D, tire development, supporting this on the quality management, ensuring that we have a clear quality on each and every tire that leaves our faculties, our plants, up to the forecasting of the markets, understanding the markets, up to the fleet services that you can buy together with our tires. Everything now is enhanced with using some kind of analytics and AI. This is the major part of what we're doing here. So on the full life cycle of the tire, we deliver some value, and we do so in worldwide locations, not only providing use cases where you can optimize your processes using AI, but also delivering infrastructure to do AI. Infrastructure is an important part which my team delivers to the rest of the Continental Tires organization. So we provide things which enable data scientists all over the place to do a use case, quickly ramp up with some tools, Python or whatever, do the CI/CD pipelining, deliver the data, collecting the data, everything. We do this quite a while now, and over time it became clear that we also need to do something on the image recognition. So what can we deliver to really support people using image recognition, specifically deep learning, to solve use cases in that area. And what we came up with, we call the visual perception provider. Visual perception provider is one contribution of AI-driven tool sets that we deliver together with others that we already delivered further, like the data science factory and the telemetry backbone. As I said, these are things enable data scientists all over the place to do their data science. So the visual perception provider, what is it? The problem is you might have product owners and data scientists all over the place for different use cases. Sure. Different use cases should have different product owners. They have their different understanding from their problem, and the data scientists want to help these product owners and support them in doing some use cases. Some are hidden here. So let's imagine the first product owner wants to detect the dimension on tires. The dimension is written on the tire sidewall. So if you have the tire, if you approach the tire on your car, even on your bike, you will see some numbers written there, and the most well-known numbers there, apart from a lot of others, are the dimension. The data scientist might get that idea, find it maybe easy to do so, and works on it. Yeah? He needs to do some image collecting, he needs to label the images, he needs to annotate them, then he wants to use a training framework, store the data somewhere, then deploy it so that the product owner and the users can use the product, and he needs to manage the life cycle of this application that he's doing there. So nice. Here we have an example. You can use a tool like Label Image for annotation. You can use TensorFlow, very popular, and whatever. And then comes another use case. Well, I want to detect the DOT on the tires. DOT is also very well-known writing on the sidewall of the tire. Department of Transport. Sorry. The Department of Transportation has unified the numbers which are given on the tire, which helps to identify in which week of the year in which plant the tire was produced. So a kind of unique identifier for the tire, which is printed on the tire. You will find it there. Starts always with the DOT. Next data scientist finds that's easy and says, I use my tool stack there, maybe a different annotation tool like CVAT, another annotation format because he uses PyTorch, another data storage, so already a different setup. Yeah. And now the big challenge always is if someone now detects, well, there are nice things, both are handling the tire sidewall, maybe we can use them together because the dimension is printed on the tire sidewall, the DOT is printed on the tire sidewall, but there are handled differently. Can we put them together? And this might result in a problem. So data scientists concentrated on solving the problem with the tool stack that he needs, that he knows and that he can handle. And if he is asked now to collaborate with another data scientist to put those things together, it might be a challenge. And that is where we came up with this concept of the visual perception provider. So the idea is that we standardize the tool stack, standardize the workflow for deep learning, specifically in the area where we work with computer vision, because computer vision creates this support for humans where usually a human uses his visual perception, which can be done now by the deep learning. We called it visual perception provider. More or less, it's a framework for data scientists to develop faster pipelines and consolidate image recognition solutions. And also because we had the feeling and the clear evidence that the images you take there, not only in the sidewall area, also in other things, they are all, sure, in our case, they are all somehow surrounded on the idea of tires, and they all are an asset. Once you go out there, take pictures of tires, or are in a plant and take pictures of tires, you have an asset. You created an asset because you have these images as data. Data are an asset. And in the next step, you label these data. You enhance the data even. And this all are assets. These all are assets. They need to be managed. That's what the visual perception provider does. So the visual perception provider is nothing completely out of the box or something completely out of another world. We used standard modules that we found on the market and brought them together in a ensemble so that they can be used as this visual perception provider. We can collect images with this. We can store these images. We can collect the labels which are given to specific features on the image. And we then have a pipeline to store these data, recall these data, recall the labels from the data, and create models based on these data. So also different data scientists who work on use cases which might go in the same direction, or where they see maybe the images could be helpful to their use case, they can just reuse all the data and stuff and go for a different object there. From all the storage and so on, we have a small environment which you can see here, where we can manage the data, the images, manage the models specifically which are there, and also deploy the models. So if a model can do the inference and detect a number, an object on an image, on a video, whatever, it can also easily be deployed, because also the deployment is standardized and templated. Okay, next slide, let me see. Yes, here we go. Sorry. So the tooling allows us now to go a predefined way. Every data scientist doesn't need to, invent the wheel from the beginning, but just can use the things that we set up and can start from there. Sure, in the tools, everything needs to be defined for a specific use case, but that's not a problem, as you will see here. So, yeah. Sorry. As you can see here, we use CVAT as a labeling tool. As anyone, also people without a strong IT background, can label images, which is extremely helpful if you have some experts which need to label very specific parts, which need a lot of expert know-how. They can use the tool. It's really easy, and specifically we decided for CVAT because you can do also segmentation. The time we started this, CVAT was, by our knowledge, the only tool which could do segmentation, and you have a huge range of different formats that you can export to and import there. So that was the tool of choice. We use Voxel 51 here to do the management of the images, to really see the labeling, check the labeling, do quality control on that. And then we go for PyTorch and do the modeling. In the beginning we started with TensorFlow, but now most of the data scientists changed to PyTorch, but this is interchangeable. We still can use TensorFlow, but PyTorch is the preferred selection here. And for our model lifecycle management, so working with different data scientists together on one model, we have MLflow, which helps us to collaborate there on the model, see the evolvement of the model, let us compare the different outcomes of versions of the model, and so on and so forth. Let me show one use case here. Our very first use case was, as I already mentioned, the sidewall characters, which need to be identified, and this is a long way, because you need to identify that you have a tire at first, and also coming from the customer's perspective, you need to identify where on the tire you find the respective writings, like the sidewall, or like the DOT or the dimension. And this is all something which needs to be in the models in there. So we put a lot of effort into the design of the data. So really to understand what is a DOT code, are there different versions of it, what characters go in there, how is the dimension usually written onto the tire, because there is a huge amount of tires, and we were from the beginning, we wouldn't restrict only to Continental tires. We also would like to be able to read tires from other brands and other manufacturers. which means you need to go into the field and learn a little bit about the field, about the domain of DOTs, what the standardization means, and so on and so forth. And sure, you also need to plan ahead how the situations when the DOT needs to be read, when they occur. What is the usual situation? Is it in a garage? Is it outside? Is it with a dirty tire or a clean tire? So different cameras could be involved there. All this needs to be really planned ahead, and you need to set up the image collection in a proper way. So before we go into such a project, we always do this planning of trying to understand what kind of images we really need to make the accuracy under all circumstances very stable, which is different if you do it in a controlled plant environment with a high resolution camera, or whether your end target is a camera from some mobile device from an end user. So we created a representative training set, 4,500 images with all labels on there. We also did some web scraping, because you can find a lot of tire images also on the web. That helped us to collect a sufficient amount of images, which then could go into the next step of annotation and labeling. We did this first internally to learn really how it works, and when we understood the process and when we understood the nuts and bolts, we had an external company to support us there, which did the rest of the huge masses there to annotate. So, but to have such an external company, you really need to understand first how you do the labeling, what are the problems there, and you can only learn this if you do some 100 labels on your own. Also, this helped us to build all the dashboards where we could quickly check problems that occur with the labeling or the images, too dark images, too light images, contrasts, whatever. And yeah, we could then concentrate on really only the useful images and their labels. As you can see here, some of the images needed to be just removed, and many of those could be used. You can see here, there we have the dimension and the DOT code over here. Same here, sorry, on that image. We need to find these areas in different perspectives of the tire. Some are rotated somehow. All this needed to be addressed here. So the model architecture was then the next challenge that we needed to solve. So first we needed to have a detector. Where is the DOT code at all on the whole tire? If it's rotated, it needs to be derotated so that we have it in a more or less straight direction. And then you need to identify each and every single tire of this DOT code. Everything was done by a different model here. These models need to be brought together and work together. And yeah, that was our first success here, which took us, I would say, almost two to 3 years to come to this situation. So don't be astonished if you start with something like that. It really was a long journey from the first images that we took and thought like, hey, now we can do image recognition because we know the TensorFlow library, to being really useful, successful in a productive enterprise environment, which needs much more than only doing some inference with some model. Let me show you a small video how this works today, so you can recognize the tire here, and you can choose what should be detected from the tire, and the algorithm, which currently still is on the cloud, not on the mobile device, can detect the dimension code, and then you can also detect the single characters in there, and if some of them are detected wrongly, you can edit them and the algorithm uses these for new labeling so that it gets better all the time. That's how it works. And then starts again, sorry. Yeah, that's basically it. That's how we handle these image recognition deep learning projects, and we are quite successful with them. That was the first use case that we did there. Up to now, we already have a couple of use cases there, not only in the free fields, in the wilderness, so to say, when you choose to take an image on your own, also in a more controlled environment, in the plants to create more quality controls in the non-manual way, which we do nowadays in a manual way. All that can be done now here. And with the visual perception provider, we are able to also industrialize these use cases quite quickly to bring them into production and run them in high scale in different plants. Thank you for your interest. If you have questions, send me a mail or find me on LinkedIn. Hope you have a nice event. Bye.